Let's talk now about the bandwidth quality of service component. With the bandwidth component, we are going to assign or guarantee a minimum bandwidth to our classes. This bandwidth is guaranteed even if the interface where these classes are sending traffic becomes saturated. And let's explain why we are talking about minimum bandwidth guarantee. Okay, let's think that this is your interface. Let's say that this is, for instance, a 1 gigabit per second interface, and it is being saturated. So you are using all the channel. So in this case, if you had, for instance, in this particular class map that is going to be called BOIP, for instance, and you allocated this class map 200 megabit per seconds, then when your interface, that in this case is a 1 gigabit per second interface, becomes saturated, then you are going to guarantee that this class is going to get this bandwidth. So, and we call that this is a minimum bandwidth because if your interface is not saturated, then your voice over IP class has the permission to use more bandwidth. So it can go beyond 200 megabit per second. That is why we're saying that we are allocating or guaranteeing a minimum bandwidth. And this minimum bandwidth happens when the interface is saturated. When the interface is not saturated, these classes can use more bandwidth than the bandwidth that was allocated to them. So let's see how to configure this guaranteed minimum bandwidth to classes. We have several ways to do so. The first way could be using absolute values. So in this case, you are going to actually write down in your configuration the amount of bandwidth that you want to guarantee for your class map. For instance, if you wanted to allocate 200 megabit per second to a certain class, you will have to actually go and write down 200,000. Remember that given we are giving these numbers in kilobit per second, this will get evaluated as 200 megabits per second because we are going to multiply this by 1000. The second way to do so will be using a percentage. So in this case, we're going to use a relative value. It is not an absolute value. It is a percentage of the maximum bandwidth that you have allocated for your policy map. So remember that this is also a minimum allocated value. The sum of all your percentage that you are going to apply to all your classes cannot go beyond 100 because remember that we're talking about percentage. And if there is a remaining bandwidth, this remaining bandwidth is divided equally among queues. Remember that each class map gets assigned a queue, and you can have up to 8 queues, egress queues in Catalyst 9000. Keep that in mind. So for instance, if you wanted to allocate 200 megabit per second to a class in a 1 gigabit per second interface, so if we had a 1 gigabit per second interface, then you will use the number 20%, 20, and this will get evaluated into 200 megabit per second. The third way that we have to allocate or to guarantee bandwidth to classes is using the remaining command. It is usually preferred to use if you are also using the priority command within your classes. Remember that you are going to use the priority command in order to establish that one particular class is going to use a priority queue. You can assign up to 2 priority queues in egress interfaces. So from the 8 available queues that you have at the egress in Catalyst 9000, 2 of those can become priority queues. So if you're going to assign bandwidth to a priority queue, then you have to do a little math here. So for instance, let's say that we have a 1 gigabit per second interface that will be your total bandwidth. That will be your total bandwidth. But you are going to allocate 200 megabits per second to your priority queue of one class. So you are allocating 200 megabits per second from the total 1 gigabit per second that you had available. That means that you will have a remaining 800 megabit per second to allocate. And then when you're using the remaining percent, you are going to refer to this value. The bandwidth that you have now available after subtracting the bandwidth that you assigned to your priority queue class from the original total bandwidth. So for instance, if you assign some class the value of 20, remaining per percent 20, you will be actually allocating 20% of 800 megabits per second. So that will be something like 160 megabits per second. And we have another way to do this. Actually, we have another way to allocate bandwidth between classes is using ratios. Notice that when using ratios, we are not going to use percentages. So these ratio numbers you can go up or beyond 100 when you add them up. So let's put this example. For instance, we have class X that we are going to assign a ratio of 50, and class Y we are going to assign a ratio of 100. If you add these two numbers together, you are going to get 150, and this is valid because we are not talking a percentage here. And what these ratios are saying is that, for instance, this class YQ is going to be assigned twice the time as the time that gets assigned to class XQ. So in this case, we will say that eventually, in order to pull packets from these queues, we are going to assign more time to the queue that belongs to class Y than the time that is assigned to the queue that belongs to class X. So we can roughly say that class Y will have twice the bandwidth as class X, but that will depend of the size of the packets and the amount of packets that will arrive into each queue. The same thing can be said about this other example here. We have class A here, and we are going to assign a ratio of 2, and for class B we are going to assign a ratio of 4. If you add them up, you get a number of 6, which actually does not mean a lot. Remember that we are not talking about percentages here, so we don't have to go we don't have to aim for 100. They are just weights. And we are also saying that in this case that class B will get assigned twice the time for pulling packets out of the queue as the time that gets assigned to the queue that belongs to class A. We can roughly say that this means that class B will get twice the bandwidth as class A gets. But that will be in an ideal scenario if where the amount of packets that arrive to class B are the same as the amount of packets that arrive to class A are, and if these packets are the same size. So this is just another way to assign bandwidth using weights. And before moving on, let's remember that we have to follow a rule. When using the bandwidth command, we cannot mix using absolute values for some classes and percentage for other classes. So if you're going to use absolute values, you are going to have to use absolute values for all your classes. You cannot mix and say one class will use an absolute value, and then another class will use a percentage value, and then another class will use an absolute value, and so on. That will not make sense. You either use always absolute values for all your classes inside a policy map, or you are going to use percentage values in your policy map. So let's see what are other ways to guarantee bandwidth. We have seen the bandwidth command, but we have another command, which is the priority command. Remember that when talking about Catalyst 9000, we have on the egress, when talking about egress traffic, we have up to 8 queues available. So you can pick up to 2 from these queues to become priority queues. In this case, or in this example, we're going to say that we are only going to pick only one of these queues as a priority queue. So for instance, if we should chose this queue to be the priority queue, we will be, for instance, configuring class voice over IP, and then inside the class we will issue the command priority. When issuing the command priority, we're establishing that this class will not have a normal queue, but this queue will become a priority queue. And if we use a number and an absolute value of a percentage, we are going to allocate bandwidth for this class. So notice that we are not using the command bandwidth for the priority queue. We are using the same command that is specifying this class as having a priority queue in order to establish also the bandwidth that we are going to allocate to this class. So we can use the command just as a summary. If you want to assign bandwidth to your classes, you can use the command bandwidth. For classes that are going to use a priority queue, you can use the command priority in order to assign the bandwidth to those classes, or you can also use police. With the police command, you are going to assign a SEER, which is kind of the allocated bandwidth that you are going to assign to this class. Remember that you can include a peer value. So in this case, the bandwidth that you are allocating to a class, if using policing, can somehow support peaks. So this will be bandwidth plus peaks. So you have those three options. Remember, you can use the command bandwidth, you can use the command police, and for the classes that are going to use a priority queue, you are going to use the command priority to allocate bandwidth. Let's go to see some examples. In this case, we have this policy map, and we are going to have class C1, class C2, and class default. In this case, let's imagine that we are going to use or apply this policy map to a 1 gigabit per second interface. And then for C1, you are establishing that it will use 20% of the interface bandwidth. So C1 will be using, in this case, 200 megabit per second. And then C2, we are going to say that it is going to use 20 megabit per second, because remember that this value is given in kilobit per second. And then the class default is going to be assigned 20 megabit per second. There are plenty of unused bandwidth allocated here. And that will be an example if I were going to attach this policy map to a 1 gigabit per second interface. But what will happen if I attach this command to a 10 gigabit per second interface? Then C1 will get 2 gigabit per second. Class C2 will still get 20 megabit per second because this value is absolute, and class default will also be getting 20 megabit per second. Notice that there is a rule that says that you can mix absolute values with percentage. We are not breaking this rule here because we are using polys in order to establish this percentage. We are not using bandwidth. Okay, let's see, and let's go for the next example here. It is actually the same example, but we are using hierarchical quality of service. So we have a parent policy here. So we have a parent policy that is going to use a child policy. So this will be the child policy. And notice that there is something interesting happening here. The parent policy map is using shaping. So it is shaping up with a maximum rate of 1 megabit per second. So the parent policy is imposing a limit of 1 megabit per second to the child policy. So from the point of view of the child policy, my complete budget or maximum bandwidth that I have is 1 megabit per second, because my parent policy is limiting my bandwidth into that value. Now, child is going to try to allocate bandwidth according to this limit, and it's going to say, for instance, that C1 is going to get assigned 20% of this. So C1 will get 200 kilobits per second. And then it will try to assign 20 megabits per second for class C2 and 20 megabits per second for class default, because we are talking about an absolute value here. And this absolute value is given in kilobits per second. So an error will happen when trying to enter this command, because you are trying to allocate more bandwidth than the bandwidth that you have available. You only have 1 megabit per second, and that limit was given to you by your parent policy. So you cannot allocate 20 megabit per second here if your limit is 1 megabit per second. Try to configure this in a device and you will see that you will get an error message. As soon as you enter here, as soon as you hit the enter key here, then you will get an error. Okay, let's continue with another example. Let's interpret the next policy map. For instance, we have in this policy map, we have this class map, we have another class map, another class map, and another class map, and another class map. So we are allocating here 20% of the bandwidth. Here we are allocating 20% of the bandwidth for this class map. Remember that each class map gets assigned a queue. So these are normal queues because we are not using the command priority. So these are normal queues, these are not priority queues. And we are assigning 20% of the available bandwidth to this class, 20% for this class as well, and 10% for this class. So the sum is 90%. So according to the documentation, we have still another remaining 10% that was not assigned. So in theory, you will get assigned 2% more here because the remaining percent not used will get divided equally among classes. So if you used 1 gigabit per second interface, this class will get assigned 200 megabits. This other class will get assigned 200 megabits, 200 megabits per second, 200 megabit per second, not taking into account this other value, just the configured value. That will be your minimum assigned bandwidth. These classes will be guaranteed to have this bandwidth if you attach this policy map to a 1 gigabit per second interface. But if you attach this command to a 10 gigabit per second interface, then this class will get assigned a minimum bandwidth of 2 gigabit per second. This other class will get assigned 2 gigabit per second, 2 gigabit per second, 2 gigabit per second, and 1 gigabit per second. So remember, the actual bandwidth depends on what is your total bandwidth, because we're using percentages. These are relative values, and in this case, the total bandwidth will be given by the bandwidth that was configured for your interface, where you are going to attach your policy map. Let's see this other example. Here we have this policy map that is known as child. We have this class, for instance, that is voice, and it is going to be assigned a priority queue because we are using the priority command here. And it is going to get assigned with the policy command 20% of the available bandwidth. So let's imagine that we had, for instance, a 100 megabit per second interface, for instance, a fast Ethernet interface. So this will mean that the class voice will be given 20 megabit per second because we are saying that it is going to use 20% of the available bandwidth. And then notice that given we are assigned a priority queue some bandwidth, then the remaining bandwidth for this case will be 80 megabits per second. That will be the remaining bandwidth because this class is using a priority queue. So we have to subtract this bandwidth from the total bandwidth to get the remaining bandwidth. And within this remaining bandwidth, we have, for instance, class C1, and we are going to assign this 10%. 10% of the remaining bandwidth. That will give us 8 megabit per second. And then we have class C2, and we say that it is going to receive 20%, but it is 20% of the remaining bandwidth. That will be something like 16 megabits per second. And then we have class C3, and we are going to give C3 70% of the remaining bandwidth. This means this bandwidth, not the total bandwidth, but the remaining bandwidth. That will be something like 56 megabit per second. So that will be the case if we were using fast Ethernet. But what will happen if we were using or attaching this policy map to, for instance, a 10 gigabit per second interface? Then class C3 will be given 5.6 gigabit per second. Class C2 will be given 1.6 gigabit per second. Class C1 will be given 800 megabit per second. And the class voice will be given 2 gigabit per second. So given we're using relative values here, it all depends on what is my total bandwidth budget or total bandwidth that this policy map can work with. And that depends on whether this policy map is attached to a parent policy map. Then your parent policy map will tell you how much bandwidth you have to work with. If this is not a child policy map, then it will depend on the bandwidth command. Remember that every interface has a bandwidth command, and it is usually automatically set to the interface capability. So if I am using a fast Ethernet interface, then the bandwidth command, it actually automatically gets mapped to that interface rate. But however, remember that the interface bandwidth command can be changed. So you can change that bandwidth. And that is the number or the total bandwidth that will be used for these calculations. That's it.